Ever pondered over the mysteries of the cosmos? Ever wondered about the birth of our solar system? It's a question that has ignited the curiosity of great minds, sparked countless scientific debates, and fueled the passion of space enthusiasts across the globe. It's a cosmic puzzle that has intrigued us for centuries, beckoning us to look beyond our blue sphere and into the vast, star-studded abyss of the universe. Well, today we unravel the cosmic story of how our solar system came into existence. Our story begins about 4.5 billion years ago in a dense cloud of interstellar gas and dust. Now, this wasn't just any cloud. Imagine a cloud so colossal that it would dwarf even the largest planet in our solar system. This cloud was teeming with the raw materials of creation, the elements that would soon give birth to the sun. So how did this happen? Well, it's a tale of gravity and the laws of physics. The dense cloud started to collapse under its own weight. As it contracted, the particles within the cloud began to collide more frequently, generating heat. This process, known as gravitational collapse, transformed the cloud into a spinning, hot, and dense core. As if pulled by an invisible hand, the remaining gas and dust were drawn towards this fiery core. This material didn't fall straight into the core, though. Instead, it began to swirl around it, forming a spinning disk. This disk, known as the protoplanetary disk, was the stage upon which the rest of the solar system would soon take shape. But let's not get ahead of ourselves. Back to our fiery core. The heat and pressure at its heart were so intense that they ignited nuclear reactions, causing the core to shine brightly. This shining core was no longer just a dense cloud of gas and dust. It had transformed into a star. Our star. The sun. But the sun wasn't done yet. Over time, the pressure from its nuclear reactions balanced out the force of gravity, preventing further collapse. The sun had finally reached a stable state. It had finished its transformation from a dense cloud of interstellar gas and dust into the glowing ball of gas we see today. And just like that, the heart of our solar system, the sun, was born. While our newborn sun was busy radiating energy, something fascinating was happening in the spinning disk around it. In this cosmic ballet, the dust particles within the disk began to interact, a dance that would eventually lead to the birth of planets. But how, you might wonder, does a bunch of dust turn into a planet? Well, it's all thanks to a process known as accretion. In the early stages of a solar system, the protoplanetary disk, a flat, spinning disk of gas and dust, is a chaotic place. Amid this maelstrom, dust particles start to collide. Now, these aren't violent collisions, but rather gentle bumps. When these particles bump into each other, they stick together, thanks to a force known as static electricity. Over time, these clumps of dust grow larger and larger, forming what we call planetesimals. These are the baby pictures of planets, if you will. They range in size from a kilometer or so to several hundred kilometers. The larger these planetesimals get, the stronger their gravitational pull becomes. This allows them to pull in more and more material from the surrounding disk, growing even larger. But the journey from planetesimal to planet isn't a smooth one. These growing bodies collide with each other in a process known as giant impact events. These collisions can be so violent that they can completely destroy a planetesimal or cause it to grow even larger. Eventually, after millions of years of these collisions and growth, the planetesimals become large enough to be considered planets. They've cleared their orbit of other debris, becoming the dominant bodies in their region of space. The final stages of planet formation involve the creation of the planet's atmosphere. This occurs as the planet's gravity pulls in gas from the surrounding disk. Depending on the size of the planet and its distance from the star, this can result in a thin, rocky atmosphere like Earth's, or a thick, gaseous one like Jupiter's. In time, these growing bodies of rock and gas became the planets we know today. The process might be lengthy and violent, but it's also incredibly beautiful. After all, it's not every day you get to witness the birth of a world. Have you ever noticed how our planets are arranged in the solar system? A seemingly simple observation, yet it reveals a complex story about the early days of our cosmic neighborhood. Let's start by taking a closer look at this arrangement. Nearest to our sun, we find the terrestrial planets: Mercury, Venus, Earth, and Mars. These are compact, rocky worlds, each with its own unique characteristics, yet sharing a common origin. But as we travel further from the sun, we encounter the gas giants: Jupiter, Saturn, Uranus, and Neptune. These planets are considerably larger and composed mainly of hydrogen and helium, enveloping dense cores. Ever wondered why this distribution exists? It's no random order, but a reflection of the conditions prevalent in the early solar system. Imagine a time about 4.5 billion years ago. A dense cloud of interstellar gas and dust began to collapse under its own gravity. As this cloud contracted, it spun faster and flattened into a disk. In the hot inner parts of this disk, closer to the newly formed sun, only heavy elements like iron and rock could withstand the heat. These materials clumped together to form the terrestrial planets. However, further out, where it was cooler, lighter elements like hydrogen and helium could survive. These gases coalesced around rocky cores, giving birth to the gas giants. This distribution of materials, influenced by temperature and distance from the sun, led to the arrangement of planets we see today. So next time you gaze at the night sky, remember, each planet in its place tells a tale of our solar system's formation and its early, fiery days. Thus, the unique arrangement of our planets is a testament to the conditions of our solar system's early days. Our solar system story doesn't end with the planets. There's more, much more. Beyond the realm of the 8 known planets, our solar system stretches out into space, filled with icy bodies, dwarf planets, and asteroids. First, let's talk about the Kuiper Belt, a massive donut-shaped ring of icy objects orbiting the sun beyond Neptune. This is the home of some fascinating inhabitants, including Pluto, which we once considered a full-fledged planet. The Kuiper Belt is a real treasure chest, a time capsule preserving remnants from the birth of our solar system. It's like a cosmic junkyard, filled with objects that have remained largely unchanged for over 4.5 billion years. Now imagine venturing even further out, where the sun is but a distant star. Welcome to the Oort cloud, a theorized sphere of icy bodies believed to be the birthplace of many long-period comets. The Oort cloud is so distant that it's influenced more by the gravitational pull of nearby stars and the galactic tide than by our sun. These regions, the Kuiper Belt and the Oort cloud, are not just the outskirts of our solar system. They're the boundary between us and the rest of the Milky Way galaxy. They're the source of many of our comets, those spectacular celestial visitors that blaze across our sky. These distant realms of ice and rock are the final frontier of our solar system. So there you have it, the cosmic tale of our solar system's birth. We've journeyed from the collapse of a dense cloud of interstellar gas and dust, sparking the creation of our sun, to the formation and arrangement of the planets, each with their unique attributes. We've ventured beyond the 8 planets, exploring the icy debris of the Kuiper Belt and the Oort cloud. This epic narrative isn't just a tale of celestial bodies. It's a testament to the intricate dance of physics, chemistry, and celestial mechanics. It's a marvel that reminds us of the universe's grandeur and our tiny but significant place within it. And remember, the story doesn't end here. Every day, scientists uncover new insights, peeling back the layers of the cosmic onion. So keep your gaze fixed on the stars and your curiosity kindled. Remember to like, subscribe, and share your thoughts in the comments below. Keep exploring, space enthusiasts.